So what we're going to do today is talk a little bit about some dataset basics, how dataset basics work, where the dataset comes from, etc. Right? Up on the screen, what I have is what we call our KC house dataset. Right? So you'll see KC means KC housing dataset. KC means Kings County. It's a very popular data set that's all over the internet. It's used for linear regressions and logistic regressions and just kind of to play around with. So I'll include a link down in the video so that you can use it and play with it and do whatever you want. When we talk about data sets, it's important that you know where they come from. Data sets are not databases. Databases, you know what? Let me do a new screen. Databases often will have input in modern times, right? We've got inputs coming in, especially today when you have all of these digital companies that have online clients and customers, and there's always activity coming in. So there's always new input, right? Amazon is always figuring out what you're clicking on, how much time you spend on a website, what you buy, what you put in your cart, what you don't buy that you put in your cart, what your spouse looks at versus what you look at. There's all sorts of inputs that go into the data sets, into the databases, right? And then we as statisticians, we are not necessarily database managers, which is a classic information systems work, but we take a piece of this. Red is a very aggressive color. Let me change it to something else. We take a piece of this and we call this a data set. A data set. And the data set is something that we're going to look at, right? So we take a snippet from the database and we say, hey, look, I'm interested in this population, right? Statisticians, researchers think very much in terms of populations and samples because we want to know who it is that we're talking about. You could say we're looking at every Amazon shopper out there, right? It's a big, big population, but that is a very difficult, large, multifaceted data set. We may want to turn around and be like, well, what do male shoppers over the age of 40 look at, right? And that's a data set that we would then try to extract some sort of analysis and a conclusion. Right? It's like that's what we're interested in. So let's go take a look at this data set. They look about the same. My data set, by the way, only has 500 observations. Yours may have more because I have chopped this down to make it a little bit more friendly, right? Yeah. So first and foremost, when you see in a data set columns, we see these as variables, right? I am looking at I'm looking at 12 variables or 13 variables, and they describe something about the observation. My rows are my observations. And in this case, what we have is 500 observations, right? So I go to any box and I hit Control and down arrow in Excel, and it takes me down to the 500th. Oh, this only has 36. Maybe that'll be easier. Okay, there we go. That'll might make it a little bit easier to see. So again, I'm gonna have to change the colors now because everything's blue. So again, up and down are my variables. And my rows are my observations. I have 500 observations. Note that down here at the bottom it says 501, but since my first row is variable titles, right, ID, date, price, etc., then I only really have 500 observations. It seems like a very small thing, but it is not trivial. We are looking at a data set with multiple hats. You're looking at it as a researcher, you're looking at it from the viewpoint of your clients, you're looking at it trying to eliminate your own biases, and we're also looking at it from an IT or a database data set management perspective, right? We need to know where things are in order to construct the mathematical analysis that we're going to do, but more to the point later. These variables, price, bedrooms, bathrooms, all describe something. They describe, in this case, a transaction. Each one of these observations is a housing purchase. So they describe a house at a particular moment in time and the price of that house at that particular moment in time, right? So these houses were all sold in 2015, and you can see over here that you have this time date stamp, which I'll do a video on later. So in 2014, 2015, this particular house was $2.9 million. It had 4 bedrooms, 3.25 bathrooms. I don't know what 2.5 means. And a 5,000 square foot living space, right? 1.5 floors, and so on. So everything that occurs on this row are characteristics that describe that one transaction. We will very often have an identification number or an identification of whatever. If you're a college student, you have a student ID. If you're any kind of student, you have a student ID. If you have a driver's license, you have a driver's license number. That number doesn't necessarily, it's not a real number, right? There are characters. It's not like I can take my driver's license number and your driver's license number and add them together. That's just ridiculous. It's not. It's just ridiculous, right? We're not going to continue on that one. So when you look at these data sets and you look at these databases, that's the very first thing I want you to think about. I want you to think about variables going up and down, and I want you to think about observations going left and right. Why do we care? Why is this important? What's the big deal, Dr. Garcia? The big deal is that when we create stuff like regressions, and this might be a little advanced for some of you right now, but if I say I want to try to predict price based off of some coefficient, beta sub 1, and square footage plus beta sub 0. This, by the way, looks an awful lot like y equals mx plus b, right? But we'll do that later when we talk about regression. You'll see very quickly and very clearly that price is a variable and square feet is a variable. So it's not that I don't care about the one observation. Oh, let me bring that back. It's not that I don't care about the one observation. It's that I care how all of the observations kind of relate to the other, to variables of all the observations relate to the other variables of all the other observations, right? This is the way statisticians think. They think to themselves, well, what is the relationship between the price, meaning this entire column, and the square foot, meaning this entire column? And clearly, this observation is different than this observation, is different than this observation, but the variables inside, let me rephrase, the variables that describe each of these observations have a relationship, right? And that's where our analysis is kind of built around, right? And we can do a variety of things with these that I'll save for other videos. But for example, I can look at the date. It's different buying a house in 2008 in the middle of a financial crisis than it is in 2014. So the prices of those houses might change, right? That's more of a time series analysis. We might want to try to predict where these things are. You'll notice I have this zip code deal over here on the right and all sorts of other stuff so that you can make a good decision either buying a house or selling a house or comparing this particular neighborhood versus another neighborhood and etc. Okay, so take a look at this and play with it, and we'll see you around.